So, welcome back, students. We'll continue our discussion on the metalworking process. So, based on the temperature, we previously described the metalworking process into two major categories. One is hot working and next one is cold working. And we just gave an introduction to recrystallization temperature. So, what is it? I will just explain it to you. Before that, let me explain why we need to go for different types of metalworking process. So, the first thing is actually why we need to go for casting. So casting is actually a process of creating material. So if you see a cast part, imagine this is a bar of cast product. So the grains are nothing but it's a globules of metals, atoms. So atoms will be arranged in this form in a cast object. So if you see here, something like this. So the grains are nothing but here these are boundaries of atoms. So atoms will be arranged here in this structure. So if you see the microstructure of any material, it will have grains like this. So some structure like this will be formed. So these are large grains. So what happens is that when a load is applied, when you apply some kind of load into this material, so it will crack immediate. It will crack. So when sudden load is applied, when you apply sudden load, what happens is that the material will crack in this region because of the grain structure, and this material will be brittle in nature. Cast product will be brittle in nature. So what we are doing is we are actually realigning the metal into a structure where the grains become small like this. So small grains will be formed. So this is the exact structure that is uh, depicted in this particular image. As you can see, these are large grains like this. So once the recrystallization is done, it becomes smaller grains. So what happens is that at the recrystallization temperature, if you see the definition now, is a process by which deformed grains are replaced by a set of free grains, smaller grains. So as you can see, the deformed grains are replaced by smaller, newer grains. So in this process, what happens is that the mechanical property of the materials are enhanced. So they become more strong, they become more ductile, they become more malleable. So these properties are enhanced by the metalworking process. So based on the temperature, we can classify the metalworking process into different things. So based on the temperature, two main type of metalworking process can be done. One is hot working and another one is cold working. If the metalworking is done above the recrystallization temperature, the process is called as hot working. If it's done below the recrystallization temperature, then you can call it as cold working. So as you see here, this is actually hot working process. This is done above the recrystallization temperature. So you would have seen in the roadside the knives being made. They will be heated, metal will be heated to a red hot temperature and then it will be beaten. So that process is actually a hot working process. So what are the advantage of this hot working process? That porosity of the material is largely limited. So since I drew this diagram, when there are larger grains, there will be porosity obviously, but when the grains are rearranged or realigned, porosity is eliminated. The grain structure is realigned, and also as I said, the toughness, ductility, malleability, property, strength are improved. So as a result of this, the metal can be deformed very easily. So whatever metal we use in our day-to-day life. See, if you're to given your automobile, the body is made up of sheet metal. So it has to be deformed. Deformed is you have to bend it into different shape. In order to do that, you cannot directly use a cast product in a sheet metal work because it will break easily. So cast product can be uh, equated to a glass. So if you apply load on glass, what happens? It breaks suddenly. Similarly, if you apply load on a cast product, it will break due to brittleness. That's why we are going for this process. And the next type of metalworking is actually called as cold working. Here, this is done below recrystallization temperature. Since the metalworking is done below the recrystallization temperature, here no new grains are formed. Rather than new grains are formed, existing grains are elongated. So this also gives some advantages. The major advantage here is that the surface finish is improved and close dimensional tolerance can be obtained. So that's the advantage of this cold working process. So the flow will be that casting will be done, then hot working will be done. Then if you need smooth surface finish, you will go for cold working. So that will be the flow of metalworking process. I hope I understood that. Thank you, students. We'll see the next lecture.